Hello guys, my name is Nur Atira binti Muhammad Zubair. So, are you ready for our lesson about additive manufacturing? Let's start now. Additive manufacturing (AM) is the industrial production name for 3D printing, a computer-controlled process that creates three-dimensional objects by depositing materials, usually in layers. Using computer-aided design (CAD) or 3D object scanners, additive manufacturing allows for the creation of objects with precise geometric shapes. These are built layer by layer, which is in contrast to traditional manufacturing that often requires machining or other techniques to remove surplus material.
Hi everyone, it's me, Kausa binti Muhammad Mansur, and I would like to share with you guys on types of processes in additive manufacturing.
Vat photopolymerization is a process that uses a vat of liquid resin, photopolymer, to create an object layer by layer. The mirror are used to direct ultraviolet light, which cures each resin layer through photopolymerization. Next, material jetting. Material jetting creates object in a similar method to a two-dimensional inkjet printer. Material is jetted onto a build platform using either a continuous or drop-on-demand (DOD) approach. Material is jetted onto the build surface or platform where it solidified and the model is built layer by layer. Material is deposited from a nozzle which moves horizontally across the build platform. The material layers are then cured or hardened using ultraviolet UV light. Meanwhile, binder jetting is a technique where it uses a 3D printing style, heat moving on X, Y, and Z axis. It's also to deposit alternating layers of powdered material and a liquid binder as an adhesive. The fourth one is material extrusion, this is the common additive manufacturing process. Use spool polymers which are either extruded or drawn through a heated nozzle which is mounted on a movable arm. This builds melted material layer by layer as the nozzle moves horizontally and the bed moves vertically. The layers adhere through temperature control or chemical bonding agents. Moving on to the powder bed fusion. Powder bed fusion encompasses a variety of additive manufacturing techniques, including direct metal laser melting, direct metal laser sintering, electron beam melting, selective laser sintering, and also selective heat sintering. These electron beams, laser, or thermal print heads are used to melt or partially melt fine layers of material, after which excess powder is blasted away. Sheet lamination can be split into two technologies, which is laminated object manufacturing (LOM) and ultrasonic additive manufacturing. Laminated object manufacturing is suited to creating items with visual or aesthetic appeal and use alternate layers of paper and adhesive, whereas ultrasonic additive manufacturing use ultrasonic welding to join thin metal sheet, a low energy, low temperature process, and it also can be used with various metals such as aluminium, stainless steel, and titanium. And the last one is directed energy deposition. Directed energy deposition additive manufacturing can be used with a wide variety of materials, including ceramics, metals, and also polymers. A laser, electric arc, or an electron beam gun mounted on arm move horizontally melting wire, filament feedstock, or powder to build up material as a bed moves vertically. Application of additive manufacturing. In aerospace or automotive industry and supplier, some parts like gear can be made using additive manufacturing processes. Additive manufacturing also can be applied in machinery industry, for example, turbines, and also special machinery. Additive manufacturing also can be applied in medical implant for dental purpose or orthopedic. Additive manufacturing also can be applied in handling and robotics. For example, parts in a robot can be made by using these additive manufacturing processes. Lifestyle and sports also are involved in additive manufacturing. For example, in jewelry, biking, and many more. And the last one is custom parts. Additive manufacturing also can manufacture the classic car parts and surgical tools.
Hello, hi guys. My name is Nurul Aimin Nadia binti Gani. So, I'm gonna show to you guys the advantages and disadvantages of additive manufacturing. Wet photopolymerization. Advantages: high level of accuracy and good finish. Relatively quick process. Typically large build areas. Object 1000, 1000 times 800 times 500 and mass model weight of 200 kg. Disadvantages: relatively expensive, limited material use of photoresins, often requires support structures and post-curing for parts to be strong enough for structural use. Material jetting. Advantages: the process benefits from a high accuracy of deposition of droplets and therefore low waste. The process allows for multiple material, parts, and colors under one process. Disadvantages: support material is often required. A high accuracy can be achieved, but materials are limited and only polymers and waxes can be used. Binder jetting. Advantages: parts can be made with a range of different colors. Uses a range of materials, metal, polymers, and ceramics. The process is generally faster than others. The two-material method allows for a large number of different binder powder combinations and various mechanical properties. Disadvantages: not always suitable for structural parts due to the use of binder material. Additional post-processing can add significant time to the overall process. Material extrusion. Advantages: widespread and inexpensive process. ABS plastic can be used, which has good structural properties and is easily accessible. Disadvantages: the nozzle radius limits and reduce the final quality. Accuracy and speed are low when compared to other processes, and accuracy of the final model is limited to material nozzle thickness. Constant pressure of material is required in order to increase quality of finish. Powder bed fusion. Advantages: relatively inexpensive, suitable for visual models and prototypes. SHS. Ability to integrate technology into small-scale office-size machine. Powder acts as an integrated support structure. Large range of material options. Disadvantages: relatively slow speed SHS, lack of structural properties in materials, size limitations, high power usage, and finish is dependent on powder grain size. Sheet lamination. Advantages: benefits include speed, low cost, ease of material handling, but the strength and integrity of models is reliant on the adhesive used. Cutting can be very fast due to the cutting road only being that of the shape outline, not the entire cross-sectional area. Disadvantages: finishes can vary depending on paper or plastic material but may require post-processing to achieve desired effect. Limited material use. Fusion processes require more research to further advance the process into a more mainstream positioning. Directed energy deposition. Advantages of DED. Ability to control the grain structure to a high degree, which lends the process to repair work of high quality functional parts. A balance is needed between surface quality and speed, although with repair applications, speed can often be sacrificed for a high accuracy and a predetermined microstructure. Gibson et al. 2010. Disadvantages: finishes can vary depending on paper or plastic material but may require post-processing to achieve desired effect. Limited material use. Fusion processes require more research to further advance the process into a more mainstream positioning.
So, for the conclusion of additive manufacturing, additive manufacturing has shown how it is as much an interesting way of thinking about manufacturing as it is a new way of constructing components. As computing systems have become more powerful, the availability of software to slice CAD models for layer-by-layer construction has paved the way for additive manufacturing to thrive. Then, a material processed by additive manufacturing will often have very different properties compared with the same material processed using a traditional method. Furthermore, residual stress is an issue for all processes that experience large variations in temperature. Additively manufactured components are no exception. So, that's all from us. Thank you for watching.